Today is May the 24th, 2014, and welcome to the Beyond Bitcoin Developer Voice Hangout. We start out this session with an update on BitShares with Dan Larimer. Then we will have Stephen Reed as our guest. Stephen will go over his blueprint on how to turn Bitcoin into a proof-of-stake currency.
Anybody, of course, can ask questions during this time.
All right, well, I'll give you a high-level overview of what we've done in the past week, which has been a lot. The delegated proof-of-stake system has been significantly enhanced. We've introduced a random number generating scheme into the blockchain. We are then using that random number scheme to shuffle the set of delegates once per round, where a round is where every delegate produces one block. The result is that we have resolved several potential attacks based on the prior implementation. We identified that someone with a small percentage of the shares could tweak their ranking in the order and make sure that they always got to produce the next block. So we had to resolve that, and that's what we accomplished this week on that front. On other fronts, we have implemented a proposal system where users of the deck, where delegates can submit proposals for consideration by the other delegates, have them voted on. And the primary reason for this was actually as a way of replacing the developer broadcast alert notification system in Bitcoin, where if there's a security vulnerability, you can post an alert. Recognizing that we didn't want to have it centralized in one developer, we decided we'd allow any delegate to submit these alerts. And recognizing that one bad delegate could spam people, we thought that it would be worthwhile for delegates to confirm the alerts. So the process works as a kind of like a board of directors. Here's a proposal, and everyone else seconds and thirds it, and after all the delegates approve it, it's ratified, and then that also helps us to handle forks. So the way I would envision things working is some delegate will propose a change. We want to change some fee structure, add a new feature. If all the delegates approve of that change, then the developers can go and implement the change. After the developers have implemented the change, they can trigger the change to take effect once all of the delegates have ratified a second proposal for activating the change on a particular date and time. The user community, the shareholders, have an opportunity then to vote against any delegate who doesn't vote the way they like. So it gives us a natural planned way for the DAC to upgrade and manage hard forks, which is something we wanted to have figured out before we could launch a DAC. Otherwise, we have a big debate outside the system without any process in place for handling hard forks in the future.
So when you're talking about the random number generator in the very beginning of it, does this random number generation invite any security risks of its own?
Well, it's a source of randomness that states that as long as at least one delegate is honest, no delegate can predict the number that will be produced the next round. The numbers that will be produced in the next round.
Wow. Okay, so it's kind of distributing that as well.
Yeah, the way the system works is every delegate picks a secret, and then they commit to their secret by including the hash of whatever their secret was into the block they produce. When they produce their next block, they have to reveal their previous secret. And if they don't reveal their previous secret, they can't produce the block. So this results in every time a block's produced, a new secret's going to be revealed. And they can't change what their secret is after the fact because they committed to it in advance. And all the secrets are then hashed in a one-way function together with each other, so that the only way to know what the numbers are going to be in the future is to know all the secrets of all the other delegates. Now, in theory, if all the delegates colluded, they could know all the secrets going into the future, and it's not really random in that sense. But it is a fair way of distributing the trust. And as long as there is at least one delegate that you trust, you can use the system. And if I own 1%, I'm going to elect myself delegate and produce a secret number, and then I can know for sure that the system's fair for me.
So, out of curiosity, this kind of goes along with another session that we had. So, for those who aren't here, who haven't been paying attention to all of them necessarily, you were talking last time about snapshots being made in the case of something, something happening that would otherwise hurt the network. You can actually have these snapshots in place as well. How would that fit in as far as with the resiliency and the security of the network?
Well, the snapshot is sort of the worst case scenario. Someone hacks the network, executes some transaction that grants them, all the coins. At that point, we can freeze the network at whatever point right before the attack occurred, fix the bug, relaunch the network from that point forward.
So both of these have, sorry for interrupting, both of these have major consequences for the BitShares Lotto DAC.
Yes, so the Lotto DAC requires a source of randomness that can't be cheated.
And it also gains the benefit of the current implementations for security last week. Is that fair to say?
Yes. So the challenge with eliminating proof of work is that it eliminates a major source of randomness. It's very difficult for miners to actually choose which block they submit because it's already difficult for them to find the block in the first place. So that makes proof of work a natural source of randomness. But if you eliminate that, you need a new source of randomness that is more efficient for the purposes of betting and gaming. And the goal here is really to make things provably fair. So we've got a system in place that will work well for people that want to buy a lottery ticket. You have to buy the lottery ticket at least one round before the random number is generated, so that none of the delegates have the opportunity to buy a ticket after they know they're going to win. And the system is fair. Now, in theory, the delegates could collude, but that would imply that all the delegates are working to undermine the entire system, and that they were selected because the community trusted them in the first place, and they're also extremely varied in different continents, countries, and so on and so forth.
So you're saying it would be pretty easy to do?
It'd be pretty hard to collude. It's sort of the Ripple approach. What you're really trusting is that the Roadrunner and Wile E. Coyote are not going to collude against you.
Sounds good. Well, we're about at the 8 minute and 30-second mark. Does anybody have any questions from the community? We have quite a few extra people in here today because Stephen Reed, who is working on Cooperative Proof of Stake white paper from the BitShares Talk Forum, is here to participate in the discussion as one of the community members and a highlighted individual for his own work.
Welcome, Stephen. I look forward to talking with you.
It's a pleasure and a great thing to be part of this forum.
You're very welcome. We invite you to come over and school everybody anytime you want to. Let us know where we need to learn, man.
I'd like to get started by reading the abstract of my paper. It's a long paragraph. I'm not sure everyone's read it, but it touches on many provocative topics that you might want to drill down into. By way of background, I'm 63 years old, and I've been early retired for some years. And during my employment, I was mainly involved in enterprise software, working for banks and large utilities and small companies. So I understand commercial transaction processing using the internet and so forth. The last dozen years, I've done AI research. I was employed by Sicor here in Austin for 6 years, where I was at one time in charge of their programmers. And in the last a few 6, 7 years, I've been doing my own AI research, but that's been interrupted by an overwhelming obsession with Bitcoin. And I think, so here's my abstract.
Oh,
Hard fork reconfiguration of the peer-to-peer Bitcoin network is described that substitutes tamper-evident logs and proof-of-stake consensus for proof-of-work consensus. Block creation rewards and transaction fees are reallocated. Establish and staff a secure financial data network capable of handling the world's transactions sub-second response time. New system pays dividends to stake offering Bitcoin holders. In contrast to Satoshi Nakamoto's mesh network consisting of competing peers, this system uses an enterprise class network that is efficient, robust, and scalable, consisting of cooperating peers. The network backbone nodes host trustless nomadic agents. Thousands of distributed full nodes are paid to replicate a singleton blockchain built upon every 10 minutes by a nomadic mint agent whose actions are verified by its peers. This arrangement enables immediate acknowledgement to an issuing node that its transaction has been accepted. Less effort means that the subsidized transaction costs will be lower. Network reconfiguration enables the processing of numerous microtransactions. Stake-weighted distributed consensus is achieved when necessary, with less than one-half arbitrarily faulty nodes. Important invariants of the Satoshi social contract between core developers and users are maintained. The reward schedule, the blockchain format, the fixed number of bitcoins, centralized trustless protocol are untouched. The system remains a global distributed database with additions to the database by the consent of the majority based on a set of transparent rules they follow. That's the abstract, and depending on the audience, I can stress how similar this is to the existing Bitcoin system, or I can stress how different it is. And when I've polled the audience in Reddit and at Bitcoin Talk Forum, there's a slight majority in favor of a change, and it doesn't really matter how much they know about the technicalities of it. They know that those who are opposed to me think that why fix a system that isn't really broken, and those who are in favor of it look to the thermodynamic effort of mining, and they say, well, that's really in the long term, it's an unsustainable activity. And I'll go with your questions to lead my discussion.
Well, I think that this would be a wonderful opportunity for you and I to, this is Bytemaster, to talk about how what you're doing is different and similar from delegated proof of stake, because I saw what you're doing and I saw your proposal and I've skimmed your white paper. It seems like we are both converging on similar approaches to solving the problem.
Well, what I'll do is, and since I'm not getting, I don't hear your questions, what I will be doing is I'll talk about the nomadic int, the nomadic mint agent. The primary difference between the system that I'm describing and the current Bitcoin system is cooperation. And one can imagine a set of people who, with a calculator, are told that they are the Bitcoin network, and the calculations of creating the distributed, rather the proof of work, are done by a manual calculator. And then you have these people who are furiously typing into their calculators, racing to complete a calculation that will enable them to collect the reward. And it doesn't take very long for one to imagine that these people, given such an onerous task, would figure out a way to cooperate and take turns creating the block with no effort. That's basically what I'm proposing for Bitcoin. That's the major difference in terms of my approach versus the Satoshi competing approach. And my approach works because I'm using tamper-evident logs, which were first suggested by Nick Szabo, but there's quite a bit of science in Byzantine fault tolerance about different ways to achieve it. And the Bitcoin method is a good way of achieving success in when you have Byzantine, which means arbitrarily faulty nodes. In the Bitcoin system, up to almost half the nodes can be faulty, and then those with a superior hash power and converge on the correct version of the blockchain, longest chain rule. In my system, the mint node is an agent. It moves around from one super peer to another, and I can talk about the network configuration because I claim that an enterprise class network can be built using the current rewards, which are amounting to about $1.9 million a day. It can be built using several, some of those days it can be built. We can build a super peer network that will host these nodes. The principal of which is the mint node, and the mint agent, which is, to be more precise, can migrate its state from one host to another. And every host runs the same code. It's simply a thread inside that particular instance that says, oh, at this moment, I am the mint. And the mint would receive transactions from the network, which is more hub and spoke than the mesh network that Satoshi designed. More rational. There'd be redundancy in it. But the transaction from the end user would reach the mint in 3 hops. And it would be recorded along the way in a tamper-evident log by each node. The mint would gather together transactions. It would reject some according to the so-called is-standard function. It's in the Bitcoin code now. And when the 10-minute mark is reached, it creates the block. And then it communicates to all the peers, the 10,000 paid full nodes, what the new hash of that block is. Meanwhile, these 10,000 full nodes are paid to replicate the work of the mint. So what they have done is they have received each of the transactions as acknowledged by the mint. The mint has a canonical timestamp on it. So each of the replicating peers, the 10,000 of those, can build the block in parallel. And then when the block hash is broadcast, they say, oh, it's the right one. That's typically going to be the case, is that they're paid and the mint is paid, and they're going to have a high incentive to behave correctly, as is the current system. There's a high incentive to do the right thing. And then there's another agent, and that's the beauty of a multi-agent system, is that you have separation of powers, so that you want each agent to do the simplest thing that's easy to verify, because that's the principle of how this works. And so I have another agent called the reward agent, and it takes the now 25 Bitcoin reward when you create the block, and it distributes it according to an algorithm that has and that the coders have agreed on, and that the community as a whole has agreed on. And that reward would be different than today's reward, in a sense that today's reward is paid to the power companies and to hardware companies to make special purpose mining equipment. I don't need to go into this because you know exactly how that all works. Mm-hmm. But the reward could be better purposed to motivate people to do the right thing for the network. I claim that it can handle all the world's transactions, including micropayments, if we just spend enough money at it. That's a solved problem how to build such a network. And the kind of network that would be built would be a backbone network with maybe 100 high performance peers. They still run the same Bitcoin code, but they're hosted in data centers. They run nonstop, so that if there's a fault in one particular CPU, there's another CPU there. They take checkpoints. They automatically restart. They have redundant communications to the communication backbones. They're co-located with points of presence from carriers, and they're put around the world. And this can be done by paying them to do it. And there's plenty of money to do that. And then we have the 10,000 paid full nodes. Right now, the Bitcoin has got about 7,500 full nodes that are, many are back level versions, and many of them run on laptops that get shut down. And so there's this issue about catching them back up when they rejoin the network. A paid full node in my system would be 24/7. You're paid handsomely. I think we could pay them $1,000 a month easily to get a dedicated a business line symmetric broadband to their home, if they want to keep it there, or better yet, a data center someplace around the world. and I described several other agents in the system. So what I'd like to do is to make the system resistant to attack, and the kind of attacks I'm thinking about would be government regulation, which says you can't mine Bitcoin or you can't process Bitcoin within our jurisdiction. Well, we need a way to be able easily to move these processes outside of jurisdiction. Nomadic agents provide that ability. A second attack would be not an attack, but a fault would be a catastrophe of some kind, say a solar flare or something, which takes out part of the world's internet, and the system needs to be able to recover from that. And enterprise networks already do this. So, for example, the VisaNet, which handles a great proportion of the world's credit card transactions, it only has two primary data centers in the United States, and one backs up the other. I'm proposing 100 such data centers, not of the same scale necessarily, because Bitcoin is so much simpler to process. It seems complicated when you look at the code, but compared to an enterprise system like what Visa does, it's quite simple. And so we can afford many more data centers that operate simply and to a great degree autonomously. And also I'm talking about a network operations center or an agent that does network operations. This is not mentioned by Satoshi. It's basically the mesh network of today is ad hoc. It's on its best effort, and it can accommodate. You can have a laptop do it. You can have a tiny little ARM chip actually could run part of the system if you have enough bandwidth. But in my system, these will be hardened. They will be the best that money could buy, and because there's plenty of money to do these things. I would have a couple hundred paid developers from using some days worth of Bitcoin revenues, and one must think also that the block reward in Bitcoin now is it's increasing. The price of Bitcoin is going up about 10 times a year on average, and the transaction rate's only going up about triple every year. And there's been proposed that there's a Metcalfe law relationship between the two, that the value of Bitcoin is related to the square of the number of users or the number of transactions or the number of addresses. And that to me makes me think that there's going to be plenty of reward in the future. At least for the next 3 years, we could see much higher rewards. And I would like to put this cooperative proof of stake system on the table for the core developers in Bitcoin to look at when the time comes that the public and lawmakers see fit to say, well, wait a minute, there are other ways to do this that don't require the building power plants or taking over some small town with data centers because the power is cheap there. The single mint is the key idea. It's hard for someone who's in the world of Napster or pure peer-to-peer to wrap their head around. Why can we centralize this thing? But the way it works is like Nick Zabel described. You have a tamper evident log, and what by tamper evident log I mean, let's start with the log itself. The log itself is a recorded. It's append only, so there's no going back and changing it. But each entry on the log is a description of some action. So there's some state that the agent had. And that state might be abbreviated just with a hash code, but some state the agent has which gets logged, and then the inputs that the agent received that causes the action that gets logged. The operation name gets logged, which might be just the C function name. And then the actions that resulted from the operation, they get logged as well. So for example, when a message gets relayed, a payment transaction gets relayed through a node, there's no state, so that's no problem. And then in my system, all the nodes are identified by a Bitcoin address, and so they can be authenticated. We know who the message came from. That gets logged. We know who the message is going to go to because of the rational connectivity of the system I'm describing. And we know the time it took place. And so an audit agent can review the respective logs of the parties and figure out, this node over here in Austin is defective. Let's isolate it from the network because it's not relaying the transactions properly. And that's part of network operations that Bitcoin doesn't address. There's aside from the alert system, there's really not much in the way of knowing about the state of all these nodes, and it's difficult for an outsider, particularly one from an enterprise financial background, to understand how all the world's transactions could be could be operated by such a system in comparison to VisaNet or SwiftNet or one of the enterprise networks that currently handles transactions. In a network's operations center, they know exactly what the state of all their processors are, and they can manually reroute things. Now, my background is recently artificial intelligence, and so an agent-based system is naturally the way I would decompose things. There are many advantages to doing so. It's tedious programming, and most commercial systems don't use any kind of agent processing whatsoever. Unfortunately, the military cares about this, and they funded Psycor to do quite a bit of research that I was a part of, the civilians unclassified research. But for decades, there's been work in multi-agent systems, and I'm just using some of those good ideas, international academics, to propose a re-engineering of the Bitcoin system.
Can I interrupt you for a second?
The process the coding process will, I hope, finish up near the end of the year. There's a great deal of the Bitcoin core system I won't touch at all. It's basically the connectivity and who gets to be a miner or a minter. Many other parts of the system will be unchanged, and a strategy I have is to try to identify parts of my system that.
Okay, since you haven't heard any of the things I was saying earlier, I like to say that I really like what you're trying to do. We're trying to solve similar problems, and be very interesting to discuss how what you're doing is different or similar to what we are trying to do with delegated proof of stake. We're trying to do the same kind of thing of encouraging there to be many different nodes out there that are paid to provide high quality of service, high uptime, high performance, instantaneous validation of transactions. So I asked a question about the rewards and how when you eliminate mining, you're talking about just reallocating the rewards to other people. In this case, the transaction processors who are going to be running these enterprise class nodes. What we try to focus on when we build DAX is profitability. And so issuing new shares or coins, as the case may be, is an expense from the perspective of the system. So do you think that you could operate entirely on transaction fees?
I could, Bytemaster, but I'm looking at the Bitcoin system. And I think the technology that I'm developing will be deployed in altcoins first. I've had an offer by the Bitcoin developers, for example, that there might be some code that we can go on. And I'm operating off a hard fork of the Bitcoin blockchain. So I'm dealing with that situation, and I think that situation, even with a halving of the reward schedule in Bitcoin every 4 years, I think that the phenomenal growth of the price of Bitcoin will lead to astounding amounts of reward available. And so I would take sort of the opposite point of view. I would say, well, look, how low can we get the transaction costs? And furthermore, I think we can pay for order flow. So now this is tricky to avoid abuse, but one can imagine paying Amazon to accept Bitcoin. One can imagine paying the exchanges to deal with my fork of the system. And I see the transaction fees as going negative in a sense. The price growth is outpacing transaction growth by, there's 10 times growth in the price, there's 3 times growth in the transactions. Now the price growth has to level off, but it may level off at the same time that the transaction growth does. In which case, I think that the additional amounts of currency that are produced as the blockchain reward will continue to swamp the transaction fees. In any case,
I think that you're got a very good point here, and I think that for this particular audience, it's very interesting to hear an alternative point of view, because what we've always been talking about is profitability. But what you're talking about is investing in infrastructure with the mining rewards. By diluting Bitcoin shareholders, you can fund development and marketing arrangements and paying Amazon to accept Bitcoin is an example of effectively a company paying to get their network to spread so you can grow the network effect. And I guess in theory, as long as you are producing more value through your dilution, it's just like reinvesting shareholder profits.
Right.
I think that's an interesting perspective.
Right, and a comment is that we're just hiding the transaction fees and monetary inflation. That's right. You're charged for holding bitcoins rather. You're charging for holding bitcoins rather than charge for moving it, and that's true. I'm just reflecting on the way the current system works. The prices are going up, even though the money is being given to miners to buy single-purpose equipment. The benefit of Bitcoin is so disruptive and so powerful. The cryptocurrency phenomenon is so much better than fiats, which appreciate, or the terrible drag of the banking system. It's highly demanded. And if I were arguing my position with Satoshi at the dawn of Bitcoin, or while it was, our paper versus his paper, then there'd be all these arguments. We could have hypotheticals in some possible world, but there is a world in which Bitcoin prices are going up very high, and I'm thinking, what can we do with the fee? It's built. The question is, what's the final solution when there's a stability in price? Well, at that time, we're handling all the world's transactions. We're trying to do microtransactions. Most of the transactions will be between software agents, not necessarily agents that I've designed, but the idea of using changes in value to influence the behavior of various kinds of software in the Internet of Things. It'll lead to messages between agents that have some kind of monetary value associated with them. It might be very small amounts. The question is, how cheaply can we handle such things? And there's debate among the core developers. They think, we'll handle that with some off-chain system. But if we have this block reward that is so large, then why not use the vehicle of Bitcoin to fund all these other activities? We could subsidize side chains, for example. With the leftover money, there's so much of it, and it's going to grow at 10 times a year, I think, for a while. And so when the system levels off, I see a world in which and this might be 8 years off when it levels off. It's hard to say. The adoption of financial technologies takes a while, but it's astounding to think what the price of.
You cut out. Sorry, Stephen.
Yeah. I was just reading the question that came to me. And I don't know if I've answered the question directly, but let me go to another one. Is an upgrade possible? Convincing miners it would better to start a separate chain upgrade or migrate tactics discussed in the paper? No, I didn't discuss in the paper. I just state flat out that there'll be a blockchain fork, and it's based on wide consensus. So the argument in the core developers now, particularly from one of the guys who's local here, Endatoshi, he's a math guy over at UT, and we've talked. The argument is they're I'd say a little bit of an echo chamber effect, but that's too strong a word, but I'm trying to get across a certain meaning, is that they think that Satoshi has this mathematically genius way of solving this distributed consensus problem, and they don't really look outside. They're not really thinking outside the box. What Satoshi did was he wanted something that would
They think that he had some genius mathematic.
Well, he does, and I can defend Satoshi easily, but for this purpose, and just give me a little bit of a leash to criticize him. That what he was doing was he's looking at Napster as the model. He wasn't looking at VisaNet or SwiftNet as the model. He was looking at Napster, where anybody can take any computer and hook up to a network, and they can come and go. He devised a software system that could recover from all of this without any supervision, and that operated in adversity with one another. And the longest chain rule is a good example of that. But if you took the Bitcoin specifications and you took them to a network engineer working for who knows who big company around the world and say, well, look, can you build a system that'll do this? It would be centralized, but then you'd say, well, look, it's got to be robust against failure. It's got to, any simple data center, every data center has got to be capable of taking out. You've got to be able to recover it in detail from any possible fault. And you say, well, that's just software. We can do that. And that's probably what I've done is I've tried to figure out a way to handle the Byzantine faults. And what I mean by is arbitrarily faulty software. And so I take cooperation as a way to go, not adversity. And with cooperation, then all the big toolbox, enterprise toolbox, is now open to us, and it's just one layer of wonderfulness after another opens up when money's not a problem.
I would say that you've hit on something I've been trying to say for a while, that the innovation of Bitcoin is not the peer-to-peer technology. It's the fact that you have transparent, auditable, irreversible, cryptographically signed transactions.
And a fixed currency limit, where it's electronic gold, and those are the selling point. That's what a user sees. And the system that I've described would give, because you've got a central mint, you have I think 6 hops to the mint and back. And in Bitcoin processing, I've done customer service for banks and a variety, all the different bank systems I've worked on, and plus customer service for a large utility where you have hundreds of relational tables, very complex things going on with a customer transaction. What Bitcoin does is so simple. It's just a journal. And the transactions are done in such a wonderfully simple way that high performance is simple. It's parallelizable and in a highly robust way. And so I think that microtransactions and a super peer-to-peer network, and what I mean by that is simply that certain peers have got to run in high performance data centers. And I don't mean big computer. What I mean is that uninterruptible power supply, you've got fire protection, you've got 24/7, the thing can never go down. And this is what the world's financial networks are run on now. And we can afford to do that. It's just that in the current system, as Satoshi designed it, there's no central organization whatsoever. The Bitcoin Foundation is in a sense sort of ad hoc. It's a bolted on, and the wrong people are paying for it. When the system is, go ahead.
So the question that always comes up is who's in control, and obviously this is a system that can be entirely transparent, and you've got this mint that's moving from place to place. It's hard to shut down. Who decides who gets to be the mint and that they're misbehaving?
Right. So the tamper evident log provides a way for the peers to check on each other, and it's made the log I described how the entries are, and I may be able to get this into the current Bitcoin system for the purposes of diagnosis. I don't think that's too controversial, especially if we can turn down and off. I'd lay a messaging system on top of on the Bitcoin network, so you'd have authenticated messages, and I'd use the standard agent-to-agent format. The recipient, the sender, the date, you've got some cookies handed back and forth to retain state in various sessions. So how does an entity get to be the mint? First of all, you segregate the nodes, and so you say out of the 10,000 nodes or the 100,000 nodes that want to connect up, you give them a test, a fitness test, and there's a paper out that I reference in my own white paper on how peers can grade themselves and form a gradient. And so you take the top 100 of those, and you say, okay, you guys are going to be the super peers. In reality, a system that's got a bunch of agents some of those agents can hire humans as contractors, and it's conceivable that we could hire one of the agents could hire a few of the worldwide auditing firms, and have them actually do physical audits on the super peers to make sure that they're geographically distributed and they are what they are. But meanwhile, you can do bandwidth tests on them. You can do CPU tests. I'm thinking about making a version of the Bitcoin client that does seg faults intentionally. I listened to your talk last week, and I thought, seg faults. I need to have that. So it could test seg faults and see how long it takes to recover from them with stated checkpoint state. And so the system knows by consensus, it knows the top 100 nodes and says, okay, you're at, and there'd be an agent to do this, a configuration agent. The configuration whose actions could be checked. All the inputs would be the utilities of the various agents, and then the ranking of them would be a sort, and that could be checked by its peers. And so the configuration agent runs once a week at a low point in transaction volume, and it says, okay, we got these 50 peers, and we're going to take turns being the mint. It might be that the mint wants to follow the financial flow around the world, so maybe it wants to be in San Francisco, and then Tokyo, and then Shanghai, and so forth.
You've identified a way for a group of people or computers to each person's got a different view, so they've all got a different perspective about the physical fitness. Now there's also a moral fitness or a trust fitness if you will, for the nodes. Is
Can
I'm pretty
I-
sure
can
that if Bank of America, J.P. Morgan, and some other big players decided that they wanted to set up these nodes, they had the infrastructure and everything that, from first appearances, everything looks good, but no one, of course, would trust them.
Oh yeah,
Yeah.
sure, exactly. So I would expect, and I expect they do now. I expect that the CIA and NSA are running Bitcoin full nodes now, or the same with the Chinese and so forth. It'd make sense for them to do that. So you have these. How do you make the agents trustless? Well, you make them verifiable. You make all their agents, all their activities have to be in a log, and that log is checked. And so I don't really care. I do care, but for the purposes of hypothetical possible world, I don't really care what kind of code is in those things or how malicious they are. If they behave correctly, then they are correct, manifestly. But there's other steps we can take. There's a technology that I wouldn't go to now, but is possible in the near future, might be better. It's called the trusted platform modules that are in servers and laptops now. The reason that they're controversial is that it's proprietary code to an extent, and it's reputedly hacked. But the idea of trusted platform modules is to sign off, get these one-way hash codes of each of the boot up process to make sure that a given computer boots up in a certain order and has a certain software running. And what I would like to do is to make sure that only the Bitcoin client that's released by the system, current version, is running on any particular peer. And if you're not running the current version and that's it, then you don't get to connect to the network. And
who gets to decide what the current version is?
Well, there'd be an agent for that. In other words, whenever you say who or what, and you're saying, well, is there some kind of trusted entity? Well, I say, well, there'd be some software agent to do that. Its code would be public, its algorithms would be public, and its behavior would be verifiable by its peers. And that's an easy sort of a waving hand way to do it, but it's a method of software engineering that I think is applicable to this. And
at some point you have to have human value judgment. You can't have a software algorithm determine which version of the software to go to. So the software in turn have to take inputs from users. Right?
Oh yeah, sure. For example, yeah. So you have a software agent that's hiring the developers, and and this is also a little bit science fiction because the first releases wouldn't have this. But if you've got $1.9 million a day to spend, I know how much DARPA spent and what it got for the systems that it did. And there's going to be a lot of money to spend on this. So if you saw how software can, Jeopardy, there's astounding amount of expert behavior that can be built into a given software system. But I'm proposing simple agents. And so for the purpose of defining the latest release, it could be the release that it's a certain website. For example, the current Bitcoin system trusts a download URL. And that's where the current release is. And there'll be the hash code to verify that you've got it. And then there could be more complicated tests that the software can
you're
probe.
mumbling out. Could you repeat that, what you just said, probably the last couple sentences?
I'm sorry.
I heard that loud and clear. I have to go here in a second.
Yes.
So I would like to just address a couple of things here, because I think you and I are both trying to do the exact same thing. We want to have incentive for large trusted firms
I think
to run
Charlie
nodes.
Daxel is making a very good point with what he was writing.
Right. So,
either of you talk to this question. It seems like a key economic difference between CPOS and DPOS is that CPOS distributes profits to the trusted parties at the top of the hierarchy to be reinvested in the company, while DPOS distributes profits mostly to the shareholders, who can choose either to reinvest or sell off. Stephen and Bytemaster, does this sound accurate to both of you?
I'd like to address that before I go, because I think that, it offers some lessons and some opportunities for us. So the key thing is, and this is the nature of control, with delegated proof of stake, I can answer the control question very clearly. The shareholders select, through the process of making their transactions, who these trusted supernodes are. And then the question is only, how do we compensate them? Do we compensate them only with transaction fees, or do we offer them stock options above and beyond the fees? So you're kind of diluting the shareholders in order to encourage investment and growth. So I think that there's something to be said for encouraging, in our system, the delegates or the super nodes to have a large income to justify competing against each other for the approval of the shareholders. We're called shareholders, the coin holders. And that when you get that, you get this large amount of money. If you don't use it to invest in infrastructure and you don't cooperate with the other delegates who have been elected by the shareholders, then you're going to get voted out. And so we have a very clear process of making sure that the individual shareholders of the system, the users, retain control over who is getting these rewards, and it's not some arbitrary thing. Now, the users can be given guidance using this very similar process to what you're talking about, fitness metrics. You look at latency, bandwidth, and other characteristics of these nodes, as well as geographic location. So I think we're both trying to do the exact same thing. We reward them with fees and with whatever other shares we deem necessary, and we have distributed control. If we can encourage the delegates to hook up directly to each other, you can have very low latency between delegates. The delegates can then perform certifiable transactions. They can basically perform the role of a server for the lightweight clients. And if they lie, they can be fired immediately, lose their job, lose their revenue. So you have very high trust system where no one's going to be able to cheat. So it seems like we are converging on the same general idea. There should be some super nodes that are compensated well so that they can justify the investment in infrastructure, and that because they have this trusted position, because they have something to lose, and they can be cryptographically fired if they cheat, the entire system stays honest for everyone. I'd like to hear what your take is on that.
Bytemaster, yes, I find it agreeable. I am learning about your system as a result of these sessions, and I think you're headed in the right direction. I believe that my thoughts are similar to yours in terms of network infrastructure. And I would say that in more detail on the point of the moderator, that the reward distribution that I'm proposing is algorithmic, but it needs to be tailored, because the full nodes in particular, their costs, I think $1,000 a month is a fair payment for running a full node, considering the bandwidth costs and so forth. But if the rewards go up 10 times next year, and it's not, I think $10,000 is overpayment, and we may get too many of such nodes, or if we put a limit on such nodes, then they will there'll be an artificial market for them, and rent seeking, and we don't want that either. So if my ideas get traction in the Bitcoin community as a result of some system tests and the utility of what I'm doing, then I would expect a symposia or something it could be held by the Bitcoin Forum, but there needs to be a meetup, a public meetup about this time next year, 6 months before the hard fork, to come up with a reward policy that people can live with, and then an annual readjustment of such a thing, given that the reward is so it grows at an almost unpredictably high rate.
I think that's a great summary. I think that I was really excited to see that your ideas are being talked about and considered in the Bitcoin community. I think it's a sign that we move in the right direction. And I look forward to working with you in the future. I think that combining your ideas with our ideas will likely result in the best possible system.
Right. A mechanism for that will be contributions to the Bitcoin core, which get sent out to various altcoins and other projects. The pieces that I add will be highly modularized. For example, the agent the messaging system will be completely separate. The idea of authenticated messages, tamper evident logs will be a separate piece that can go. And these will be reusable pieces that others can try out before it gets accepted into the Bitcoin deployable instance. But I look forward to taking code that others have developed. In particular, I need a test harness. I need something to prove that 10,000 nodes are very robust. I need to prove that the system I'm coming up with is tougher than the Satoshi system. They can recover faster than the Satoshi system. That there's less uncertainty about what the blockchain is about, and I need a distributed test harness to do that. I know that they've given some money to a team in Barcelona to build such a thing, and I need to get in touch with them to do that.
Yeah, I think that there's ways we can cooperate with technology, but also just on the idea space. For example, you need to figure out how to price the rewards. Well, if our BitUSD bit asset system works as we expect, you can have a market establish the price, and then you'd have to manipulate the market to push the price high or low. And that's sort of a way of reaching decentralized consensus on what the rewards should be. Someone else asked the question, what's the crucial difference between CPOS and DPOS? And I would say that we are agreeing in principle. I'd say the primary difference is how the delegates are selected and what they are paid.
Right. I as I look into it, it was an agent-based technology. I would use the proof of stake as sort of the last resort consensus. If something's really gone wrong and you need to get some kind of consensus as to which part of the system to ban, then I would use the proof of stake for that. But I don't put it into the blockchain. I don't need it for the longest chain rule or anything like that.
Yeah, the longest chain rule is really only in the event that the network is split, and if all your robust supernodes in the collaborative proof of stake system are completely disconnected because of cables cut in the ocean, they're going to know they're disconnected. But they need to figure out some way of handling transactions that occur on both sides,
right.
Figuring out who has the majority.
Right. So I'm not even sure that's worth programming, because it's a circumstance that could happen in the Bitcoin world. But if you've got a supernode system and you've got network operation centers that have got either intelligent agents or people watching over them, they're going to rehearse this. They're going to have system tests that say, okay, we just lost China, or we just lost Asia. How do we fix this? And I don't think we need to worry about the system having these complex rules, that are invasive into how the whole system is designed in order to handle these catastrophes. We've done all kinds of enterprise stuff where we practice. What if we lose half the CPU? How do we do our tonight's bills? And we just work through it in terms of procedures. So I'm not really worried about the split brain problem so much, but I will test it. I'll demonstrate that the system can handle it, but I don't think it has to be invasive into the code.
I think the primary, it doesn't necessarily have to be in the code, although having it in the code allows for rapid and automatic pre-approval of what the process should be. I think what the market is looking for with all of these systems is that there is a set of rules and procedures that are defined and that will be followed. And as long as they're followed, no one has any complaints. The problem we have with our current banking system is that the rules and procedures can be changed in arbitrary ways that hurt people for the benefit of others. And it's the arbitrary changes to the rules and the lack of transparency is the problem we have with our current system and why Bitcoin is so popular. And I think that as long as you have that, whether they're human manual procedures or software procedures, the system works. The only thing that is left is how much transparency do you have if you rely on human procedures? How much opportunity is there for human error if you're relying on human procedures? And what's the performance? How quickly can the humans get it back on track versus an automated solution? But I think overall there's definitely going to be many different systems. I don't think there is just one network. But I think that you're doing great work, and I'd love to continue working with you.
Likewise.
Well, it sounds like you guys had a pretty dang good conversation there. I didn't want to interrupt the entire time, so I hope that you guys, I'm not interrupting now. I know that Bytemaster expressed that he had to leave at some point in time. I hear kids in the background, and I know we all have other lives. So, Bytemaster, I don't know, are you feeling like you're going to have to head out, or?
Yeah, I've got to go. I've got to spend some time with my kids. So thank you guys very much for having me. I'll talk to you all later.
Thanks for attending again, man, Bytemaster. As for Stephen, you had me as soon as you said separation of powers. That to me tells me that you are working in a way to keep things decentralized as far as the power structures. And
right.
I've had conversations with people saying, is it possible to put into the blockchain or a constitution of sorts, between different networks. Different networks are built to have different kinds of power, and they all compete amongst each other to have that power and different things like that, keeping to those tenets. I'm not a brilliant super mathematics genius like you gentlemen are, but I like to bring the community here to talk to these brilliant people and learn, and to also offer the opportunity for people to ask you guys legitimate questions along the way, because one of the keys to me for opening up a broader user base is giving people the understanding and teaching them.
Yeah, so I'll talk about the separation of powers first. In agent-based programming, what you do is it's all about how the system behaves, and so what kind of behavior do we want the system to have, and then for each behavior you can decompose that, and it's sort of like a functional-based system where you can decompose a function into more primitive functions, an object-based system where you can decompose objects into lesser objects. Agent-based system is asynchronous. There's messages going back and forth, and there's conversations back and forth between these agents, and so it becomes a powerful mechanism for decomposing and complex behavior, in particular intelligent behavior. Because what you can do is you can take something which seems like it takes a great deal of intelligence, but it can be broken down into a number of simple things. And so the separation of powers, what we do there is it's a form of trustworthiness. And I look at the United States government with its separation of powers and the executive, the legislative, and the Supreme Court. It's less efficient than a kingdom, but it is far more trustworthy in a sense that you can get a failure in one piece and the other two pieces will compensate for it. And so I use separation of power. Separation of powers is to create lots of simple agents. A critique of my paper is that, look at all these complicated things. It's going to be impossible to test. But the tests are the same that you'd want to give to Bitcoin. You'd want a network running lots of nodes, and you'd want these Byzantine, that is arbitrarily faulty things happening, and you'd want the system to do the right thing. And so that's the way to test it. And then you use code coverage tools to make sure that all your agents were exercised and all the exceptions were dealt with. And then regarding the blockchain and so forth, I think that people need to keep their minds way open. It's a mind-expanding thing to think about what's possible. We're starting this the way I start is I say, well, wait a minute, we've got 10% of the world's economy that's in the financial infrastructure right now, and that's a boat anchor drag on what this world could be doing. And when that's removed, what would be possible, and what replaces it? For example, the Bitcoin is and cryptocurrencies, for many of them, are deflationary. So that means that all of credit goes away. There's no more credit. How does human behavior change? What do we need when there's no credit? If you want to buy something, you just wait for it to get cheap enough to buy. And that's that sort of thing going on. And regarding the blockchains and putting a constitution in the blockchain, I would leave the blockchain exactly as it is. There's a conservative principle among the developers, the core developers, don't change anything that works. And so I would leave the blockchain, the transaction format, all that stuff alone. You can add new things to the messages, but what goes in the blockchain, I would sort of leave alone. And there could be parallel databases, like I'm calling these tamper evident logs. They'll end up bigger than the blockchain because they're more voluminous. But they're in parallel. I don't actually put that stuff into the blockchain. Although they work the same way as a blockchain, they'll be hashed together in chains and they'll be signed. And so I think of the constitution between these different entities. I look at it as an agent-based thing. I just would say that there are different agents, different if you will, a DAC is a community of agents, if you will. The technologies that I lay out, the message passing is something that any distributed is it autonomous or anonymous corporation? What's the A in DAC?
Autonomous.
Autonomous. All right. So there you're talking about agents. And so an agent-based system of all different kinds is possible. And the agents that run on the supernodes can talk to agents running elsewhere. And the supernode providers may choose and be paid to run agents that are not necessarily the agents that I'm describing. It might be agents that have a commercial value or some other nonprofit value to be there. And I've been thinking about artificial intelligence for a long time, how to build it, and we don't need for the Bitcoin system to talk to us yet. But down the road, I'd like to be able to have a conversation with it in the way that the sort of the Turing test, and my expertise over many years has been in conversational dialogue systems. Bitcoin doesn't need that now. But I would see the network operation centers maybe being a way to do that. I would say, like, where's my transaction? What's that node doing? And be able to talk to it in English and get an answer back. That's sort of where I would go after these first problems are solved.
So interesting. You're right. I mean, it is a mind expanding thing, for sure. I would love to go off on that topic. Delulu asks, though, apart from political decisions, with respect to the system and the technology, what he sees is the importance of covering the weak points of D posts and C posts.
Well,
currently, as you see them.
Right. I don't know so much what the weak point. The weak point of your system is that it's a system from scratch, and the strength of my system is that it's the least modification that I can make to Bitcoin Core, and my revenue stream, if I succeed, is assured. And your revenue stream, if you succeed, is more in doubt. That would I look at it from a business standpoint. What the relative things are. I've heard others say, Bitcoin might be superseded by other coins that are more innovative. But I know from my watching what's going on I've subscribed to the various forums, and I'm watching changes and pull requests, messages from core developers over the last few weeks. I'm getting a flavor for how they do it. And I've worked in enterprises where we did such things in-house. And I can see that I think I'm on the right track by trying to modify Bitcoin as it is and make the smallest changes to accomplish things. And then laying out a technology platform that can be built upon in a much easier way than the current system can be built upon. I mean, the sidechain technology is important, but it's not really out yet as to what it can do. But if we have agents that are running, financial agents that are running on Bitcoin system that can interact with other agents doing things in DAX, where people are in a hierarchical system or a distributed system of some sort. Some of the agents are highly automated, others represent people, and I see this as this is coming out of some military thinking of a few years ago, how they could do a command structure with people in the loop, and it's explored technology, and the trustless nature of how you can trust an agent by observing it. These sorts of things were thought about for weapon systems, and I'm actually anti-military, but I've been employed indirectly by DARPA for 7 years, and worked on projects I worked on a project called Total Information Awareness that was discredited, but it turned out to be exactly what the NSA put into place that Snowden revealed. He's a hero in my regard. These ideas about distributed agents and so forth have been explored under conditions of life and death in the military. They've thought about it, and I think they're workable, and they're widely applicable and in the commercial and the real world for much greater good than they were first envisioned by.
I'd like to ask another question. So my basic assumption about every system is that no system is perfect and that every system has a weak point. So Stephen, what would you say is the weak point of your system, and what would be the weak point of the depot system? If you agree to the basic
I'll pass on the weak points of depots because I'm not in a position to criticize it beyond the simple-minded stuff of the business model. Weak points in my system is the adoption of it. It's a big change to a system in which powers against me are vast in power. They're entrenched and they don't want to change. For example, the chief scientist of Bitcoin Foundation, Gavin, has stated that he doesn't care about mining. That when asked, he gets asked this frequently at conferences now about proof of stake, and he says, well, in the future it'll be transactions that finance everything. The block reward will drop fast enough where this issue won't be important. But he's not really paying attention to the price history of Bitcoin. And I do. I'm an investor in Bitcoin, and I care about the price history, and I've modeled it on the Bitcoin Talk forum. And it's been going up 10 times a year, and we're hardly getting started in terms of adoption of cryptocurrencies. We're down. We're 1,000 times less. We're 1/6,000th of the volume of a Visa, for example. And so I'd say the weaknesses of my approach are trying to get it adopted by the core developers. And then technically, what the weaknesses are is that unlike an enterprise system, it's scattered. It is. In order to adhere to the Satoshi contract, the Satoshi social contract, it's got to consist of these trustless entities. And a rational way to do it would be like one enterprise owns the whole thing. They own every physical location where the servers are, and they hire all the people who touch those servers, and they can use all the professional tools in place to make those things happen. And so the weaknesses of my system, I think, are the weaknesses that Bitcoin itself has brought along from the legacy, Napster world, where you don't have control necessarily. You don't have physical control or hiring control over the people running the nodes. And because of that, there's a greater amount of faults that take place than otherwise would be the case. And the spending the money, for example, if I were to say, well, Amazon, I'll give you $20 million if you'll start taking Bitcoin, which is 10 days worth of revenues from the mining reward. There's no real mechanism to do that. There's no marketing budget. There's not a clear channel for doing that. And so I'd say that another problem that I may have is scalability in terms of when peers check each other's logs. There is as long as the number of connections between peers is small, and each peer checks only a dozen or so peers around it, or checks them randomly at suitable intervals, there's not a problem. But if every peer is checking every other peer, then we get we get an order of complexity related to the square of the number of peers and the square of the number of messages and so forth, and it becomes a very scalable big issue. But my strength as a software engineer, and I appreciate the comment about me being a math scientist or whatever. I'm not, and I have a degree in applied mathematics from a university, but it's only because they put the computer science department there, and all my math courses were not so hot. But I am a fair software engineer, and from that standpoint, scalability and tuning systems, that's what I really like to do. And so I think that when it comes down to testing this and scaling it out, I'm a good profiler, and I think I can make this thing scale. I really do. I've got a lot of confidence there.
Now, out of curiosity, sorry if you do. Go ahead and ask a question.
Okay, so you were saying that core developers like Gavin Andreessen, they reject proposals like yours because I didn't really get the reasoning he puts forward, and because a system like yours or a system like a proof of stake system would just make it more efficient without lowering the security if it works.
Right. So what Gavin does, if you look at his recent talks, like he gave one at MIT where this came up, the first question to him, in fact, I think was about proof of stake, and he doesn't answer the question directly. And the talk on the Bitcoin forums is first, they're scientists, that is the eggheads, if you will, in that group, they believe that the Satoshi approach is mathematically optimal, and they believe that proof of stake or any other approach fails to solve the distributed consensus problem that Bitcoin proof of work uniquely solves. And because Gavin he's not really a math or crypto scientist, and so he just takes their assertions, his peer assertions, as the starting point. And he doesn't really try to get in those arguments. He sort of just says, well, look, the mining reward's going to go away. So what's the big deal? And I have two criticisms for both those points. First, on the math point, is that the scientists or the math people inside the Bitcoin group are not really looking at the science, or the academic work on Byzantine fault tolerance, which started even before Satoshi or Nick Szabo were talking about it. And there's quite a lot of academic articles on Byzantine fault tolerance and how to handle it. And the chief case is that it's relatively inefficient, but if you have 1/3 or fewer faulty nodes, then there's a way to have liveliness and what they call linearization, which is correctness. But if you have remote attestation of a tamper evident log, then you can provide replicas of a central server, which I'm doing. In other words, Mint is a central server. It's nomadic, but for the moment it's central. And I've got 10,000 replicants of that being built in simultaneously. The science of this, according to the academic article that I cite, is that something less, if you have 50% or more, a little over 50% of true correct nodes, then you can continue. But they'll look at the science. I brought it to their attention. Greg Maxwell in that group has been the appointed one to explore sort of new things. And if Greg likes it, then Gavin, I think, will start to listen to it. But what I'd like, the way I'm trying to handle it politically, is to have a solution in place that code speaks for itself, in a sense that if I've got a system that can robustly handle seg faults and all kinds of malicious things, and it's got a system test, and I can run Bitcoin, the released version of Bitcoin on the same system and show that it doesn't do as well in terms of recovery time, then I think I can convince them. But it'll be a slow pull for the next 12 months until that happens. I'd say those are the weaknesses: scalability, and because I'm confident that the agent thing will work, but there'll be the complexity of having these different agents. Each one opens a possible attack vector, and as I put these things into code, people are going to say, well, what happens if there's no configuration agent? What happens if the configuration agent lies and the system gets misconfigured? Well, I'll have to have a test case for that, and I'll have to show that, there's a way to recover.
Okay, I get that, and so I mean, I get the idea that you have the agents, and they are all open source, and this way everyone can approve whether it's trustable or not. But where do the agents run? Like, are they also? Can everybody run an agent, or is it just run on one machine?
Right. So the agent is a thread. Each agent is one or multiple threads in the Bitcoin software instance, and every software instance will have the ability to run one of these agents. But in most of the 10,000 full nodes, they'll be turned off. The only agent that they'll run is a relay agent that relays transactions upstream to the mint and downstream acknowledgments back to the issuer. And they'll also have an agent that builds the blockchain in replica of what the mint is doing. And so the agents will know, each node will know what version of the agent they're running, because I'll have a configuration node that puts out a schedule once a week. It says each node is identified by a Bitcoin address, and it'll have an associated IP address. And there'll be redundant ways to get to those. So if they lose one broadband connection, there'll be a backup to try to get to them.
Okay, backups. That answered my question. Thanks. So another question I have, and I have to admit that I only read half of your paper. I liked it. So the question would be, I'm sure the question is not answerable easily, and it's a very general question, but The DPoS approach is roughly relatively simple, and they are just there's just one instance of supernodes, right? And with your approach, you have all kinds of nodes. You have the supernodes, you have the mint, you have the you name it, right? What makes it necessary that you have so many different instances of nodes? What is the structural necessity for that? If you can answer it that way.
Yes, I can. Yes, I can answer it easily. And I'm sorry the paper's not more clear. But there's two different views of this, and the first is a network infrastructure view, and the second is a multi-agent view. As I get more accustomed to giving this presentation, I'll try to be more clear. The network view is simple. It's a super peer system. So when peer-to-peer came out, the mesh networks were criticized for poor performance, and academic research came up with this idea of a super peer system. So you identify a small number of these peers, and they'd be highly connected to each other, and they'd have superior capabilities, the ability to take perhaps thousands of incoming connections. And they form a ring, or a system in which each of these super peers, I'm talking about physical computers with network connections now, each of these super peers would be well connected with each other, and they each would be a hub out to spokes, and the spokes would be the clients. And in our case, those would be full nodes, and then beyond the full nodes would be the SPV nodes, the things running on your Android phone. And so that's the hardware system. The software system are these multi-agents, and so I propose that they're nomadic, and having movable software agents is a solved problem. Software stays in place. It's only the state that gets passed from one node to another. When the mint closes in Shanghai and opens up in Frankfurt, it just transmits its current state, which in the case of the mint, it's not very much. It's just where I am at in the blockchain, and it would and then another one, it would restart at the new location. And I propose at least I've probably got half a dozen or a dozen agents. There'll be many more, because each problem that comes up, rather than make it each new behavior that needs to happen, it might be better to create a new agent to perform that behavior than it would be to make more complex the behavior of an existing agent. And agents are allowed to be subordinate to each other. So an agent can process a message on behalf of another agent and respond. And so you can have hierarchies of agents, and you can decompose behavior in the same way that you do it within a functional programming or an object programming language.
Okay, so what you're implying is is the following true? Because you don't have a system like in the DPoS system where the shareholders select the trusted delegates or the trusted nodes, you have to have different instances of agents that bring in the trust, and those have to have different functions, and their functionality is separated. So which divides their power, and therefore makes the whole system more trustable. So is that a comprehensive? Is that a correct summary?
Yes.
Great. Okay, and the other question is, or the other thing I would assume is, you have the super nodes and you have the full nodes, right? And is it true that the only reason there's a separation between those two is that it scales more this way if you separate?
Yes, exactly. So we have a system. Today's Bitcoin is just full nodes, and there are some distinguished full nodes that run at mining pools or at exchanges or at payment processors that are the most important nodes by virtue of the transactions that flow through them, but they're not otherwise distinguished in the hardware infrastructure. And so a super peer network simply rationalizes that responsibility and creates more of them than there currently are. So I say we need at least 100, and I would suppose that the number of nodes currently in the mining pools that create all the blocks for current Bitcoin, there might be only a dozen of those, maybe half a dozen in the payment processors and exchanges that are really important. So I'd have more nodes, and they'd be worldwide distributed, and they put them on. I'd make sure the infrastructure was at least as good as what Visa and SwiftNet use. And when I say SwiftNet, I mean the wire transfers that happen between banks.
Great. Okay, cool. I have to say that I have to go as well. But what I want to say is my perception is that the BitShares community greatly appreciates your input, and we are very, very open to what you're doing, and we are very thankful that you are sharing this with us. And maybe a suggestion I have would be that we make a second more technical session where Dan could get into the details of your approach. I'm not sure if he read the white paper completely, and you could read the DPoS white paper completely, and then we could have a more technical discussion about the pros and cons of both systems. And the interesting question is also whether the difference between the two systems in the end only is because you are starting from with Bitcoin and want to change as little as possible. If that is the reason for the differences, or if it's an entirely different system that comes in the end from your background as an artificial agent guy, right?
Right. I agree with you. You're very perceptive, and you've despite my poor way of saying things, I think you have it entirely. So what I'd like to do is I have the paper printed out. I did a very good, I think I did a good survey of the literature before I wrote my white paper. I didn't include Dan's as a reference, but I was familiar with BitShares, and I also know that he's changed some. As you write code, of course, the implementation will differ from the white paper. But I will study the white paper and be prepared to offer more intelligent comments, more well-informed comments about your system next time. And it could be soon, or it could be in a few weeks. I am at the moment I've got to attend to getting myself well integrated as a contributor to the Bitcoin core. I'm trying to find the least objectionable changes to make to the core that'll get me get a history of successful pull requests. Get that started. So I'd like to do that for a couple more weeks, and then that will give me a chance to study the paper and prepare much better for the questions that you're posing.
Sounds great.
Well, I wanted to really quick. I don't know how long you're here, Stephen. This could go on as long as you want to, or as little as short as you want to.
I'll tell you that my wife is running out of patience because we're laying some tile in the kitchen. I don't have children. I've got grandchildren. I've got plenty of time otherwise, but this is very important to me. This is the work of a lifetime from a person who's had a long and happy career in different things. This is the most important thing that I've ever done, and it's a great honor to. In fact, it's scary, the ambition of what we're trying to do to disrupt the world's financial systems and beyond. And so my time, I can go a bit longer. I want to. I'm very highly motivated to do so, but it's not unlimited because I have an issue of domestic peace.
Oh man, I wish that I could say it as elegantly as you do. That's wisdom right there, Stephen. You've been married for a while.
My wife supports my work, and so she has leverage.
Well, that's very good for her to know, and that you put this out publicly. With that said, there's a couple things real quick that I want to clarify. DeLulo is one of the people who is going to be taking over some of these sessions. So when he's on, we all ask questions, but you'll generally hear questions from a few of us a little bit more often. Wanted to have something where they could ask you in the chat or ask you here. With that said, I didn't want to speak up while he was asking those questions to get to the big topic that you guys were covering there. I want to let you know, in BitShare's community recently, they were talking about launching a DPost chain of PTS and keeping the other one, which is actually essentially based on BitShares. Bitcoin.
Right.
And they mined it effectively. That's what they're doing with it. And there's been a little bit of community consternation based on how they were going to do the social consensus, if they were going to get rid of the old proto shares system, where it might frustrate some of the people who were mining it at the time. It was something that I don't know if it would be possible to work and add on to different altcoins, like a multitude of different altcoins, to see if your solutions work.
Yeah. I've been approached by a person claiming to be a Bytecoin developer, and the original Bytecoin was just I believe a Bitcoin clone. It faded away. Then the new Bytecoin, I think, is a written ground up, and I'm unfamiliar with it. But I would offer my code, particularly early next year, early in 2015, to altcoins that are very similar that have a similar blockchain to Bitcoin and want to experiment with a single mint, or they want to experiment with agents that communicate back and forth to each other, or they want to bolt on tamper evident logs and just try that. I need to get my code out in the wild, and I'm a Bitcoin partisan. And I don't invest in altcoins. I actually have 3 mining rigs that I'm leasing for Bitcoins that are being used to mine script algorithm altcoins right now. I'm a Bitcoin partisan. That's where my focus is going to be. Yet I need to be a part of the innovation that's taking place in the altcoin communities, and I'm willing to offer all my code and be supportive of its being played out in the wild, and supportive of certain modifications of that code that would fit whatever ideology that a particular altcoin has.
With that said, I'd like to go on real quick. Well, first off, I'd like to thank you for answering my question. But Joey D is saying, from his history in the Army, he knows firsthand how hard it is to try to change a culture, and that was a hierarchical culture with a lot of power. So how would you, Stephen, think you could convince people to change the culture, especially if it could take years?
Well, the first, I'm socially inept. My wife is the first one to say that, and so my first thoughts when I did this was, oh, why not just take it over? Why not do a hostile takeover? Money's there. I mean, if you can get your hands on the $1.9 million a day, you can buy all the developers you want. You can pay off the people that need for this to happen. And I could make a case that Satoshi himself laid this open. He said, well, look, if somebody else comes up with a more appealing software, the miners will adopt it. Well, I'm taking the miners out of the system, and so they'll be resistant to it. So I've tried to be more socially listen. I try to listen more now to what people are saying, and one of Gavin's objections to proof of work at the very beginning that's been written down has been that it's just a way for the rich to get richer, and that strikes the heart sort of what my initial approach. I had a post on a provocative post on the Bitcoin Talk forum back in April, so I was exploring these ideas. I said, well, look, 10% annual Bitcoin dividends can be ours if we switch to proof of work. Download software to support this change, or would you download software to fight this change? The vote was 44 in favor and 40 against. And so right there, I knew that it would be possible to take over the blockchain, but it would be very divisive. There were very contentious posts, bitter, that I would think about disturbing or changing something that worked. And people have billions, collectively billions of dollars in the current system. And if the hostile takeover takes place, well, certainly the market cap would take a dive for at least a little while the issue was in play. So that was one approach, and it's an approach that my ego sort of said, oh, we'll just take it over. No, because we're right, and I could be wrong, and I could be destroying Bitcoin trying to save it. So a better approach is to listen to what everybody is saying and try to incorporate their objections as system tests that the system has to prove that it's better than the current system. And then I can just wait, because if I've got a working alternative, say proof of stake, or getting rid of somehow of the effort of mining proof of work, I'll just wait for the legislatures around the world to realize that, hey, we don't have to spend all this electricity. I mean, if we have got laws here in the United States that say that we have to use a certain kind of a light bulb, then we can have laws that say, well, look, if you're gonna have a cryptocurrency, it's got to be created a certain way. And there's a treaty actually that many nations have signed. There's an energy treaty that many nations have signed that says that they will encourage, respectively, in their jurisdictions, energy efficiency. And so there's already a framework in place to ban Bitcoin worldwide, and it can be done by the energy part of our legislatures. And I can imagine that Gavin would get hauled into a Senate panel or a congressional panel and asked to explain why Bitcoin is proof of work when it could be proof of stake, and look at all these other altcoins that seem to be doing very well. Why? So the approach I'm taking is to listen to the developers and try to be a team player. I've been part of big organizations, different ones, and also small startups and consulting and so forth. And I can be a team player. I can sing in a choir and blend my voice, so to speak. And that's the approach I'm going to try to take through this year. I've got some helpers and people who are encouraging me on the Bitcoin Wizards IRC channel. And they're respectfully answering my questions and so forth on the Bitcoin Dev, and I'll stay off the mailing list for Bitcoin development, because I don't have the credibility or the responsibilities that those people have. Not yet.
With that said, I do want to let you know we're going to go ahead and post a topic to this BitShares forum to discuss your approach, and people can answer your questions there, and you can answer their questions there. So I invite you to go there and set up an account. And I know that for a fact that our entire community there was a pretty long thread. There are a lot of people who are very interested in your concepts because they mirror in many ways the kind of philosophy I think that they're moving towards in the BitShares community with regard to these different proof of stake solutions, right?
Right. It's not so much a proof of stake solution as it's something else than the proof of work. In my solutions, I look at it more and more. It's the proof of stake actually is not so much important. It's the idea of cooperation rather than competition among the entities that make up the network. How do you verify what they're doing?
I think we generally have a consensus then that we are done for the day. Stephen, I will thank you greatly for coming on. I will urge you to use this as many times as you'd like. We feel this is a good place to bring people together, because right now there's this concept that we have all these altcoins, and all of them are, like you said, in competition. And I get that way myself sometimes, feeling that way. So it's nice to have other people come in and kind of ground you, and like you said, kind of break up the echo chamber. Yes. And I feel like the conversation between you and Bytemaster, a lot of the time, we all learn from not only YouTube, but you guys learn from us.
Yes.
Generally speaking. So it's always nice. You're welcome to come on anytime. There won't always be a large group of people here, but I can assure you that the more devs come on to teach people about the technology, the more people will come here at all times. And eventually what I would like to see and create is a format where you guys can come in here, have a meetup that I don't even know about, have people join up. You drag them into the room. They can ask moderators if they can come in. People who weren't invited, you tape them. People who are there can record it. You could record this entire conversation in the Rumble server. So it breaks down the barrier to entry, and substantially increases the ability to propagate that information that comes from these sessions. I do know the vision from our forums is worth Let's Talk Bitcoin now, and he's producing a show for them, with them, or what, not with them necessarily, but posting the forum posting the content to their site. So we're getting it out there. It's going to take some time, but it's going to be the community and you guys who really let it bloom. So it's there for you, Stephen.
Great, and I've just bookmarked your forum link that was posted. Great. I appreciate the time that you've given me, and I apologize for sometimes being disjointed and technical difficulty that I could have so easily overcome earlier had I been aware of it.
We always have little things at first, right? Eventually it'll get to the point where we'll know how to quickly fix all of it for us. Thank you everybody for attending. This has been another Beyond Bitcoin Mumble session, Dev Hangout. We will be coming back to you next Saturday, the 31st, for Bytemaster's weekly conversation with the community, and we urge all of you to try to find representatives for your own community or represent your community here and bring along a couple devs for everybody to talk to and learn from. Thank you for your time, and have a format just